Let's jump right into today. We're going to talk about variables. We're going to talk about data types, and we'll talk a little bit about string formatting, although string formatting is kind of the second part of Module 2, so we'll hit that kind of next week. What I do want to end with today is a little bit of time covering Sandbox 2, and I'm going to give you time in class to work on Sandbox 2. You may or may not be able to finish it, just depending on how much time you take to play around with it. Before I jump into those things, though, I want to talk a little bit about Python in the general sense, so you can get to know the language a little bit about its history, where it came from, and kind of how it's developed over time. The reason for that isn't because I'm going to test you on it or because you have to memorize all of this, but it is helpful to understand where Python came from, so you understand, so you sort of get a sense of the language itself and what it's about, what it's commonly used for, and that sort of thing. So let's jump in. Python was invented by this man. He looks so happy that he invented Python, doesn't he? Guido van Rossum in the late 1980s. And he actually wasn't necessarily a computer scientist, but he was a scientist who was using a different type of software, a different programming language, to analyze data and conduct research. And as he was using that other language, I believe the language he was using was ABC, and that is the name of the language. He's Dutch, by the way. So he was using this other language to do his work. He discovered some things about that language that he wished were different. Some commands that he wished he had, or some capabilities that weren't there, or things that maybe were too difficult that should have been simple in his mind. So, like many inventors do, he decided to fix his own problem by creating something new. And so he created Python. And Python, unlike the logo in my slides and things, is not named after the snake. It's actually named after these guys, Monty Python. Maybe you've seen this movie, Monty Python and the Search for the Holy Grail. People generally either think it's the dumbest movie they've ever seen or the funniest movie they've ever seen. But these are, so Python is actually a tribute to Monty Python. True story. Later on in the development of Python, the people who were heavily involved in the development of Python actually created these rules, or these statements that sort of represent what Python is. And they called them the Zen of Python. And they're sort of a set of ideas about Python that represent how we program with Python and what Python is meant for. And so the first one says, beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated, flat is better than nested, sparse is better than dense, readability counts, and special cases aren't special enough to break the rules. They don't really necessarily make a lot of sense until you start using the language. But we will talk a lot about these principles as we build programs, because they're really true. Like, beautiful is better than ugly. Maybe you're saying, well, how does that apply to code? I've seen code before. It all seems kind of ugly to me. As you learn more about writing code and learn what good code looks like, this will make sense to you. Because as a computer science instructor, I can assure you I've seen some of the ugliest code ever written. I've also seen some really beautiful code. Beautiful in the sense that it is sophisticated and elegant and easy to read and easy to follow. Those are the things that make code beautiful. Saying things like explicit is better than implicit. What that means is saying things is better than assuming things. I'm sure you probably heard the saying that when you assume, you make an ass out of you and me. It's sort of the same thing with code. You want to write your code as if you're writing it for somebody else, as if somebody else is going to read that. Because even if another person doesn't read that, somebody else might actually be like you next week after you've walked away from your code for a few days and completely forgotten what it was you were doing. If you don't make your code readable, I guarantee you that will happen. It's happened to me a million times where I walked away and it takes me a minute. I have to stare at my code and think, okay, what was it that I was doing here? Sometimes I make little notes to myself in the comments, which is valid, by the way. But things like simple is better than complex, complex is better than complicated, flat is better than nested. We'll save those for a little bit later down the road as we build more complex code. Sparse is better than dense. What that means is you don't have to write your code in a block that's all crammed together. You can leave blank lines. You can leave white space. That actually helps you. I don't know. It feels a little bit claustrophobic to me when I see code that's just a solid chunk of lines of data, right? I like to see some white space. If I have a section of code and then a different section of code, I like to leave some space in between them. You'll develop your own style that makes sense for you. But what I like to see when I write my code is plenty of space. There's no reason you don't get bonus points for cramming it into as few lines as possible. You get bonus points, kind of, if you can read later. So what are the things that make Python so great? And if there's any question about how great it is, I will answer that in just a minute. But it is great, and it is the most popular programming language on the planet. Verifiably so. It's easy to learn. Yay for you. It uses more natural language. What that means is Python uses words and commands and constructs that if you read them out loud, kind of make sense in English, or make sense at least enough that if you read a line of code, like print hello world, you can kind of figure out what it's going to do because the words that it uses kind of make sense. Kind of. Not always, not 100% of the time, but if you compare it to other programming languages, you'll especially see this. It's very versatile and extensible, meaning it already does a lot of different things. But even better, it was built so that you can add stuff to it. So if you're like Guido van Rossum and you're sitting here and saying, man, Python's pretty good, but I wish it did this, or I wish I had a command for that, you can just make it. If you want to use Python to connect your Ring camera to your internet connected toaster so that when you pull in the driveway, it starts making toast for you, you can do that with Python. You can do all that stuff with Python. You can control robots, you can do AI, you can analyze data. It's probably the most versatile language on the planet. And it's used by a ton of people. It's got a great user community, which means not only do a lot of people use it, but those people that use Python actually have websites out there where they post tips and they share code and they are involved in groups that figure out problems and figure out the best ways to do things. And then the good news about that is that it's easy for you to find helpful information on Python online, no matter what it is you want to do. And that thing about the Ring camera and the toaster, somebody might have already done that. And so you can find their code and you can say, well, that's pretty cool, but I want to make sure that I have another camera on the dog to make sure the dog's outside if it starts making toast because he likes to jump up on the counter and eat toast or whatever. Like, you can do all that stuff. It seems a little crazy, I know, but even though I just pulled that example out of thin air, there might be somebody who's done that. Here is the Tiobe Index. Okay, this is a company that uses software to analyze other people's code. Companies hire them, big companies, to run their code through their software, and their software says this code is efficient, it does what it's supposed to, there's no dangerous security loopholes. So this software company is a very big deal. But what they do is they keep track of who's using what language. So they have hundreds and thousands of customers, and so they are able to keep track of who's using what language and how popular each language is. You'll notice right here, number one, this year in August 23, August 24, still number one. It's not just number one by a little bit. The rating here is 18%. I'm not sure what the percent refers to be honest, but it's a big margin. It goes from 18 down to 10 is second place. Second place is C++, C, Java, C Sharp. C++, C, and C Sharp are all very similar languages, as the name gives you a hint. Java and C++ are classes that we teach here at BC. This is the B11 class, the B12 class. We teach JavaScript, and on down. We teach PHP. So these are a ranking of those languages, and you can see how it's changed from last year. But they pull those companies every month. So each month you can come in and see what's the most popular language. I can tell you Python's been the most popular language for several years, and it's not even close. So that's kind of interesting.
The ratings are based off the number of skilled engineers worldwide.
Mm-hmm. Yeah. So Python, I was in a meeting literally last week, and my department chair just made an offhanded comment where he said, I don't think there are that many full-time jobs out there where people are using Python. And I looked at him and said, sorry, I'm going to have to push back on that one. Mostly because I know. One example, though, is my son who works at Microsoft, who's a professor here. He spends a lot of his time coding in Python at Microsoft. But look at all these companies. All of these companies use Python in a production environment, which means their end product is somehow reliant on Python code for what it does. So are there jobs in Python? Absolutely. Yeah. Do you need to know more than just Python to get those jobs? Yeah, maybe. But Python is a popular language, and it's used by all kinds of companies for really important work. So it's a really powerful language as well. These are all things that you can do with Python. Web development, data science, machine learning, artificial intelligence, robotics, game development, scientific computing databases, embedded systems, Internet of Things, and much more. So what can you do with Python? Almost anything you can imagine, really. There is one particular aspect of Python that's important for you to understand, at least on some level, okay? Again, this won't be on a test or anything, but it's important for you to know. Python is what we call a high-level language. It is also what we call an interpreted language. And what that means is that your computer doesn't understand Python, right? It doesn't understand Python. It understands ones and zeros. There are languages that are much closer to what the computer speaks, like assembly language. There are languages that are called compiled languages, like C, C++, where you write something in C++ and then you send it to a program that compiles it. It translates it, just like these ladies are doing here, translates it to the language that the computer speaks natively. So the advantage to those programs is that because there's no interpretation happening, the computer can run that code very quickly, very efficiently. Python is different. Python is an interpreted high-level language, which means the language that we type, the code that we type into the computer for Python is not what the computer speaks natively. It actually requires a Python interpreter, right? As some of us have found out. Some of you, when you went to install PyCharm, found out that your computer did not have an interpreter. So you had to install the Python interpreter. So when I write my program in Python and I hit run, it sends it to the interpreter, which translates to the computer, back and forth, and then it produces some kind of output that I can read or does what I want it to do. That's good because my Python program is always written in Python code. I can read it, I can change it. It's easy for me to test because if I write something in C++, I have to write the code, and then when I want to test it, I have to compile it and then see if it works. If it doesn't work the way I want it to, then I have to go back, write the code, compile it, test it. Now, once I get that code dialed in, it runs really fast. Python, I can write it, test it, write it, test it, write it, test it. I don't ever have to do that compiling stuff. It's quicker, it's easier, it's a simple way to develop code. In a production environment, in an environment where there's a lot of traffic or a lot of use of that code, Python is a little bit slower. In this class, it's really it's basically a fraction of a second, a few milliseconds difference between a compiled program and a Python program that's being interpreted. You won't notice the difference. You wouldn't notice the difference. Two programs written in different languages that do the same thing. However, if I'm writing code that is running on a public-facing web server at Google, where it's getting 100,000 hits an hour or more, that difference, that few milliseconds difference, can cost millions of dollars a year in electricity. Just a few milliseconds difference between one program and the other. So that does matter, but it only matters for really big programs or programs that are getting a lot of use. So in this class, for the purposes of learning, Python is perfect. For many applications, Python is really great, just not for everything. Knowing when to use what type of program and what type of language is important. So it's just important. Keep it somewhere in the back of your mind. Oh, Python's an interpreted language. That makes it easy to learn, easy to use, not quite as fast in running the programs.